Okay. Hello and welcome to this live coding session, continuing the implementation of the HTTP server from scratch in C. Today we want to look at responses and get curl to accept my messages, which didn't really work until now. So this is the first thing we're going to look into, and hopefully it works. We might actually start serving out some HTTP sites. We'll see how far we will go. So let's pull up. Let's pull up tmux and sorry, still a little sick. Let's pull up tmux and start implementing. I don't know if you can hear the rain. It might actually be quite loud. And of course we have to change the title. It's day 5. Okay, let's do this. So, we left off trying to construct a response. I mean, what we really want to do is probably return as a response right away, which is just a string, but we can also create a header map. But for this we would need an arena. I think first of all we should try and make it work with some basic hard-coded value. That would be my best guess, I suppose. So we had in http.h we had some hard-coded things here. Our OK response. And I think there is no nice way in C to concatenate arrays. This would be another advantage of using Zig, something like Zig. But okay. Is there something like a const cast C++? Okay, there is a const cast. So this might help us. Const cast. Type conversion as a declaration of the expression. Is there an example? Okay, const cast. We can try it. We can try and undo the things we did here. Is there some nice way to do this? Comma. Yeah. Okay, same thing for this. C string, null terminated string C++ to U8 array. Does that work? So this is a reinterpret cast. Let's try to do this. And this says const cast and then U8 star. Something like this. Const cast U8 star. Const cast U8 star. So I don't know if this actually works. Const cast U8 star. And I don't know whether this works at all. If we can get the size of this. Okay, so this does not seem to like what I did here. Const cast. Oh, this is a method. Or whatever this is. From type const char to type invalid const cast. Is it a reinterpret cast? Const cast versus reinterpret cast. Is not compiled to any. Only the following code can be done with, except for an expression of integral enumeration pointer or pointer type. Pointer to member type can be converted to its own type. Okay. Reinterpret casts. shit. Oh man. Initializer failed to determine size of Reinterpret cast. So this is what we were trying to do. Okay, so what if we just call it a day and say it's a car star? Okay, you are a car. I don't care. Does not. Only the following conversions can be done with reinterpret cast, except when such conversions would cast away constness. So what is a static cast? I mean, I don't want to get into all of this. If expression is an L value of type CV1 base, so this is a reference to B. This is a reference to what? Okay, this has to do with inheritance. Yeah, this has to do with inheritance. I don't even want to get into that. So I just want some memory. C not include null terminator and string. I think we can only have that. Okay, so now I think there are some issues. Because we said U8 is... Yeah, because we expected it to be a U8 all the time, while it's not. So either we change it to I8 everywhere, So either we change it to I8 everywhere and call it a day, or we cast it all the time. I think we actually want to change it to be a car. That will make it a lot easier. Sorry. So now we have to, of course, exclude the null terminator byte. And yeah, just I think it was like this. Const expr space. So this is also car. And let's say const expr u32 http version prefix length size of http version prefix -1. And also this has to be -1. So we don't want the null terminating byte in there. Okay. Do we have any other hard-coded strings? Yes. Default response length. Let's make this a U32 as well. And as we change it, okay. So now we have to change all of this stuff. We can make this a car star. And everywhere we use a U8. No, not everywhere, but in most of the cases we want to use a U8 now. So let's see. Comp time hash. So this is comp time hash is in HTTP header map. And this now takes a const car. Okay, so now the string has to become a car star as well. Okay, and we messed up something. Okay, where const expr? Const car. So this is gonna be painful now. This is gonna be painful. So what does that even mean? Field value. No known conversion from brace and close to initialize a list to const string. What? Can it string? Okay. Where do we have it? I think we start by looking at this here. This is a car star now. And this is a car star as well. Anywhere else? So go to http.cpp and now we return a car star. Car star, car star. I think this method, I hate this method here. To do make this more safe. I don't like this method here. It's very shitty, I guess. Car star, also a car star. Let's make it car star everywhere. Sorry. Car star. This takes a car star, returns a car star. This is a car star. This is also a car star. This is a car star. This is a car star. This is a car star. Yeah, basically you have to replace it everywhere. Just to be able to don't have just to be able to don't have this finicky of defining these hard-coded strings as arrays. Yeah. This is not, so move this into a constant. So is there anywhere a U8 star? Yes. Okay, car star. Oh no, this is a U8. This is a car star. U8 star. No, U8 star. Because I'll know U8 star here. Sorry again. So everywhere here we have to replace this. U8 star with car star. mem.cpp, and it's the same thing here. This might introduce bugs, but I hope it doesn't. Star, car star. Okay, lookup response. This is in the HTTP header map. No, this is an HTTP. Lookup response. Maybe we did not save the header. No. Oh, okay. One could also read the error messages. But that would be too easy, I guess. And I don't even think this is the way we want to do it. The U8 stars, they keep coming up. Okay. Okay. Parse header. Unsigned car. This still a car star. Invalid conversion. From value pointer. Value pointer. Let's see if we still have a U8 star in here. No. Okay, so now it compiles. Let's see if we can do something here. 123, run, and 2. Let's see if we can do something. So let's see. Sorry, I'm distracted. So curl -x get localhost host 8080. Next. Oh. Hell yeah, brother. We introduced some bug. Oh no. We probably have somewhere a size of CRLF. Size of. So this is something we should not do. And CRLF lang, we should use this one from mem. Okay, so there is our problem. So this should be the CRLF length. Oh no, 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 no. God. Oh, I hate it. So, CRLF length. And also the CRLF length. So is there anywhere else? Okay, so this is also wrong. HTTP version prefix length. HTTP version prefix length. So this obviously does not work anymore. So the only place where we use size of should be in the header files and where we allocate something, and yeah, in here. Okay. Okay, so let's see. I think it was 1, 2, 3. Yes. Break 1, 2, 3. Run. Curl. Okay, now it's correct. PHTTP header. So we have something. Header map. Buckets. 100. And we have something. Yeah, so this is nice. This is also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It matches. Okay. Seems fine. So in our header map, what we probably want to do is serialize it. Yeah. But first of all, let's just try to make it work with some hard-coded things here. So this would be this, then the content length 0, carriage return line feed, carriage return line feed. So when we have get, we look up the response. HTTP server. Okay, so that now did work. So it expects content length. I didn't know that it is required. So that is here just the max HTTP header size. We may define this as invalid header or corrupted header. In our HTTP, we just say const expr char star corrupted header, and this is kind of the errors. Is equal to car star -1. I don't know if this works. No, http.cpp. Replace car. Does that work? Car star -1 with corrupted header. So in here we can actually check for corrupted header. Max HTTP. So it doesn't like that. Reinterpret cast from integer to pointer. It doesn't like that. We could just say this is a pound define corrupted header. Okay. So we just use the preprocessor. So, and this works. Let's say the content length is 2. So we actually have content. HE. Hey. Say it's 3. Hey. We get something back from curl. Nice. Nice, 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 nice. So basic OK response should be just this. And in our post thing, so when we set a post, make HTTP server, so this should be true for post as well. So when we say curl-x post, localhost 8080, and we do put some data there, hello world, this works. If we don't put data, it does work as well. Okay, so our server is able to receive requests, parse the header, parse everything out, and put some basic response. Now, our basic response is in fact very basic and pretty stupid because it's just hard-coded strings. But we can change that. We would actually have to assemble a response. And I think this HTTP response. So we already have something that is called an HTTP request. Maybe we want to rename that into. Maybe we want to rename this offset. Status code. So I don't think we actually need this here. Max HTTP header size. Oh no. So this did work because the last one is just 0, but transfer. Let's introduce host header. Header name. Content length string, host string. And let's introduce some lengths here. Name with length. And this is the size of transfer coding encoding. Transfer encoding header name -1. This is no. This is the content length header name. Content length header length. This is crazy. So this is the size of the host header name -1. And then we just use this here, which is the transfer coding, no, encoding header length. This is content length header length. And this is the host header length. Okay. Same thing here. Transfer encoding header length. Content length header length. Oops. Host header length. Okay. So in here, what we wanted to do is we want to. So this is not. We said that this is a message, that this is a header, but this is rather. This is rather a message. So let's say that this is a HTTP message. No. So this is this doesn't really work. This is more the request. So this is like an HTTP request. HTTP request, and this also has a car star message body. So this becomes an I16. Okay, so now we actually have to make an HTTP response, and the response also has a status code, HTTP status code, it has a version, and so it might have a reason, car star reason. It also can have a message body and a header map, and I think this is it. So now we have to go back into http.cpp and our parse header, and this is more like a parse message, http message. So http or request. Request. Nice. So, and this does not do this, but rather this. I don't like this limit, but so down here, so the good thing is that we defined, we can just replace this here. That's nice. But we also have to set the so if this is greater than or equal to the limit, we say HTTP, and now we set that this is the header, but this is rather the request. So this is the result, message body is equal to null, otherwise the result message else message body is equal to the message body start pointer, and it also needs a length, which so this is more or less a string. Header feed line end pointer. So this probably needs a length as well. And the length is the limit, but so let's replace limit with message end pointer, and it's the message end pointer minus the message body. So let's say the message length U32 no, it's more like a usize message body length, so the message end pointer minus message body. If message body length is less than 0, less than or equal to 0, message body length. Okay. And return 0. I'm pretty convinced that this doesn't work. So main.cpp. Where do we have it? In the... So this HTTP request. HTTP request. HTTP request. No, let's just call it request. And HTTP header request. Okay. GPU request and okay. Parse header, parse HTTP request. HTTP HTTP request. I16, yes. So this is so if this is equal to this, then we do this. Message body start pointer. So we don't need this. We just need the request that might or might not have something. Handle post request. So this is now very convenient. Message body length, HTTP, message body length, message body end pointer, no, message body start pointer. We define it as an I size. Yeah, it has to be an I size. Cannot convert. Okay, so HTTP, we didn't say that this is a string. Message body start pointer and message body length. So this should be correct, if I'm not mistaken. This is a string. This is a string. And a string should have a length. I think Why? Why are you yelling at me? Is it dot pointer? Dot length? Why does it think that the message body is a car star? It is not. My... Oh. Because of this? Oh, because I only did it in the request. Oh my goodness. That was stupid. So let's see. Make HTTP server. HTTP server. Okay. So let's see. Let's see if this actually works by looking at let's handle post request. So break handle post request. Let's just look at the request now. So print the request. And we have a message body of length 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we have a content length of 11 as well. So this looks right. Does it mean I did not screw anything up in the inside the parsing and that it is completely safe? No, it does not. So also we have to introduce proper error handling using the RFC. Okay. So probably if I would just... Oh no. Okay. So that works. In here, we probably need some allocator to construct the response. So this is an HTTP response now. Or maybe this is an I16 as it can return an error probably. No, this actually, if it is an error, we can just return the response. So HTTP response. HTTP response. And just do this for now. We now need some way of serializing the response. So this is nice. We need some way of doing this. And this is probably the HTTP thing that should be responsible for this. And this returns a car star serialize response. This takes an HTTP response pointer to it. And also probably an allocator. So yeah, because we have to allocate. Okay. I think my camera actually follows me again. Okay, now it doesn't. I hate this gesture control, man. Please, stop. So we want some serialization of the response. So if we handle the get, we get an HTTP response, HTTP response. And what we want to do is we get a car star. No, it's more like a string. We get a string, serialized response, This can probably fail. String response string if we cannot serialize, we probably also want to close the entire server socket and make sure to close all client connections. So this is probably something that should not fail. This can only fail due to allocations. We could also assert this, but okay. And we probably give it some response string reference and the response. And then we don't want to look up this. We just say this is the response string dot pointer, and this is the response string dot length. Same thing for this. Okay, So now we have to go back into our http.h and get back here, get a string star, and return an I16. So now the next thing would be to implement this. So first we probably need a size, and the size is determined by the status line size plus the header size plus the message body size. But I think most of the times we don't have that. So determine the size of the resulting string. And the thing is, we probably don't want a arena allocator here. I think this is not the right allocator. I think we want a stack allocator in this case, such that we can free this after sending instantly. So this is also a problem. Yeah, probably we want a stack allocator. So what is the idea? No. What is the idea? We get a request. We get a request. Let's close these tabs. We get a request. A request. Oh my goodness. A request. Oh my god. And that request has some things in here. And maybe it requests index.html. So we parse that, we parse the request, and then we construct a response. And that response probably just has a content. So what does the header map of the response look like? Then we want to serialize. So request, parse, construct response, serialize, response. So the question is here, do we need sorry. Do we so do we need a dynamic header. Do we need a header map? Or is a list of headers sufficient? I mean, in the end, we just have to iterate over this. In the end, we just have to iterate over this and construct. So maybe we want a header list. HTTP header map. And we also have a header list. That is almost identical to what the map is, but just being a list. And we don't need any get shenanigans here. So maybe we say copy HTTP header map.h HTTP header list.h. Yeah, that was wrong. Source and so that might actually be more what we want. So we don't need this. We don't need this. We don't. This is a HTTP header. This has a field name and a field value. And the HTTP header list just is a. It has a length and a capacity. It has an arena allocator and it has HTTP headers. We don't need the hash. We don't need the hash. How do we even? Maybe we don't even want to do this. So push init clear destroy HTTP header list. HTTP header map HTTP header list. So pushing would, yeah, that would be true. 2 strings. Or maybe just an HTTP header. Yeah, I think we need this because we want to add headers later, like CORS, cross-origin resource sharing. I mean, for now, we probably don't need this. We would just need a content length And the content length, it would be in there. So should we compute the content length in this method here, or should we compute it in the serialization and append it? This is the question. I think we want to do it in the serialization, but we can also give it a hint. Like, if we are in here, we probably know the size. So the content length is also just the length of the message body. But we also, okay, so no. So I was confusing that. We also have to compute the entire length, which is everything. So the content length has to be specified here, I guess. And the entire length should be determined by the serialization. So let's maybe start with the serialization thing. But I have to pee first. See you. Okay. Fresh tea. we might even so fresh tea, and on we go. So this would be more like the lookup status line. So now the serialization takes part. And I think this is not so nice. So we want it to be very general, or at least something general. What we want is probably a stack allocator. And what we probably also want is a size hint. Probably size hint. And in mem we probably need how do we do this? Should we have some string that should we have a vector of strings that are pulled together in the very end? I don't know. How do we assemble this? I mean, I already know that we won't have a working version of this by the end of today's stream because we didn't even implement a stack allocator. But I mean, what would be the most straightforward way of doing this? Oops. Yeah, scrolling through everything. Nice. So what would be... Maybe we open it up again. What would be a straightforward way? Have some string at the very beginning with some capacity. And then serialize all the fields. So we have this message. This message struct. Oh, that's a terrible curly brace. And serialize all the fields. And when we serialize the field, we just push it onto the string. I think this is somewhat the this is probably somewhat the nicest way of doing this. The problem, of course, that I see right now is that we always have to, like, I imagine that at the start of this, so we have the server, and when it spins up, it looks at the static www folder or something, and that folder has some files. And the server goes ahead and reads these files and does an mmap. And we have some mapping of the file name and the pointer. Yeah, and what we would have to do is when we assemble this, the message body, we would have to copy all of the content of the file into the string. But I think we don't really have another choice. Okay. Maybe we look at Rust HTTP server. Probably use a certain oh my goodness. Serialize and serialize and deserialize, great. Yeah, I think we just do that. What we could also do is push all of the strings. Onto some vector of strings, and then assemble it in the very end. I don't know which one is actually faster. So yeah, maybe if we have the size and it's not that bad, maybe just call allocate, and we allocate so we allocate size hint times the size of a car, which is 1, but we do it anyways, and we do it on the stack allocator. So this is the result. This is the response. This is the alloc. Okay. So allocate using the alloc, and this can obviously fail. Oops. I think our arena allocator actually, no, it does avoid stuff. So we cast this to car star and say car star result pointer. Oh my god, I have to cough so. Sorry, still a little sick. Okay, so we allocate this here. And how do we do this? I mean, we should have. Should we introduce to our string should the string be a vector with a capacity such that we can push onto it? I don't think so. Or maybe we do two things, that is define a string and a fat pointer. Or what we could just do is obviously say push. But this is not very nice. Then the string would also need an allocator, and that would be not so nice. Push stir. Is that something we might? So this is this is something we might want to implement in mem. So I don't really like this. So this is, to me, this is really a pointer type, not a string. But we use string a lot, so I mean, we can rename this to Maybe we have to rename this. I'm not sure. Struct dynamic string. I don't like this. Okay, so okay, we have a dynamic string, whatever. No, I don't like this. Ooh, I don't like this. I really think this should be a string and this should be, I don't know, pointer. But dynamics, come on, just, okay. We use dynamic string. Or a fat pointer. So restricted pointer, maybe. This is also not very nice. So let's say this has methods in it. And this init. Takes a stack allocator. All what we do is we extend the type inside our HTTP. We say, so we don't want to expose this probably. So struct how do we call it? A string vector. And this has a string, inner string, and it has a capacity and this thing can basically push stir onto the string vector. And we push some string. So this is the destination, this is the source. And we also need an allocator here, so stack allocator star alloc. So push stir if dest capacity, no, if No. So this is dest length plus source length is greater than or equal to dest capacity. So this is the inner string dot length. Then we want to make some space. So we want to say alloc pop note the stack allocator should be exclusive to the string vector, as it would free memory arbitrary memory otherwise. So we want some mem copy so the new dests in dest capacity is equal to 2 times dest capacity. And we obviously now have to allocate. Oh no, that doesn't work. We would have to pop it first. Oh no. Can we make it different? When we allocate a new one, then this is the top of the stack. And when we pop, this will screw us over. But otherwise we can't grow it. Can we somehow do it? I mean, we would have to copy it into the new buffer, but the new buffer doesn't exist. So we would need a second stack allocator. I think with 2 stacks it would work. Then we allocate on one, but we would have to remember on which one it is. So, and we would I don't like this. No, I don't like this. So maybe we can grow. Maybe we can grow the last chunk. So that might actually work. Grow if grow so I think then we can just do it with the arena allocator as well. Arena allocator. If we implement a grow, so we say grow, and we don't need to copy. So this is nice. We don't need to copy now. The capacity times the size of a car. Grow. And now we just have to mem copy. Into, so the car start pointer is equal to the destination inner stir dot pointer plus destination capacity start pointer from the source using the source dot length. We copy this. We set the dest capacity times equals 2. And I think this is it. No, this is also wrong because we want to start at the length. And here we want to say dest length dest inner stir dot length plus equals source length. Okay. And I think we can just do it outside of this. We copy it in here. Oh no. Here we set the capacity. Grow last. Okay. So this is more or less the let's call it result pointer. So let's say the string vector strvec is equal to size hint and some inner string that is and dot inner star that is equal to the pointer, which is the result pointer, and the current length, which is 0. It can merge. How do we call this? So in the end, we want to deallocate the string. What we could also do would maybe be keep the string. But I don't really see a point in doing that. I mean, we can probably shrink the arena. At some point. We can probably shrink it afterwards again by the, yeah, probably this is what we do. So now we say we want to push stir, and the thing is we don't know how to serialize numbers. This is also a problem. We could hard code it, which would be convenient. But also, do we want to do that? I don't know. Yeah. I'm not so sure if we want to do that. I mean, we could also keep this thing. But we also want to allocate some other memory to this. Probably. Yeah, okay. I don't know. So we probably want to push something that is the so most of the some things are defined in HTTP, some things are not. This is kind of not very convenient. We want to push stir the so this takes the stirvec, I guess, and also an arena allocator. We want to push stir and then the HTTP version prefix. Do we have a string for that? No, I don't think so. And HTTP version prefix length. And I think they want a reference here. Maybe we make a string out of this. Exper string HTTP version prefix. HTTP version prefix HTTP version prefix length. HTTP version prefix string. And a reference to this. Okay. Sorry. Okay, so we push this prefix string. I mean, it could always be the same. Like, we don't have to do this. But okay. Let's say push. Then we want a the version number. So let's for now just hard code it. Let's just hard code it. I don't like that this is all in here. Let's say const exper HTTP HTTP version 1.1 string one one So this is obviously pretty shitty how we do this. HTTP version 1.1 size of HTTP version 1.1. Oh, we could also do a push const char. I mean, a const char has a size that is known at compile time. So when I think about this, this should work. So push stir push const char. Let's push const stir. So this is just a const char star. And this is just the size of this thing. And the size of the source. Anywhere else? Yes, here. The size of the source. Okay. Okay. So push, this would be push const char, and this is just the HTTP version prefix. And push const char. No, const stir. The HTTP version 1.1. Okay. This is an I16. This is an I16. And if this is equal to -1, return -1. If this is equal to -1, then return -1. Okay, so we have both of these. Now we want to push content length. No, for all of the headers. So this is probably int I is equal to 0, I is less than the response header map and .len, I guess. ++ I, and the current HTTP header star current header is equal to response header map and then headers dot headers and ++ current header. And now we just want to push stir alloc stir vac and also the value can now be a No, it has to be string. Okay. Stirvac. And now the field name. Maybe push car. Push car. And yeah, start pointer is equal to source plus this thing. This is also the inner star. Same thing here. The inner star. And here the inner star dot length. Okay. Push car alloc stirvac, and we want a double colon, and now we push stir field value. We say the string field name. Oh no, it's more like the current header field name and the current header field value. So this serialization, does it have to? No, we can directly write. We don't even need this. So I don't think we actually need this. So write response would more likely be what we want. Is that more what we want? I mean, we can directly write it out to the socket. And we don't need to allocate anything. I mean, this is something we could put into our main even. base32 file fd. HTTP response. We don't need this. We don't need any of this actually. We don't have to allocate. We don't. And now we just use the write call here. Instead, and oh no. So we just use the write call. That uses the file descriptor, so this is the HTTP version prefix, void star HTTP version prefix length. We write out this. We write out version 101 to do actually consider using the HTTP version provided by the response, not just a hard coded field. And this is the same thing, right? To the file descriptor, so void star HTTP version 1.1, size of HTTP version 1. HTTP version 1.1 -1. HTTP version 1.1 length. And we say, okay, right. FD void star field name dot pointer. So it's okay. Let's say string field name current header field name field value current header field value field name dot pointer field name dot length field value dot pointer field value. Is there something like write car? Okay, I don't think this is so. Write a colon, write this. And I think then we have to write the carriage return line feed. So write fd void star a carriage return line feed 0f length. And then we write the message body. So if response dot message body. We write this out. Response message message body dot pointer. Response message body message body. This is the message body pointer. This is the message body length. And all of these things have to be wrapped around in a if statement. In an if statement, if this is equal to -1, return -1. If this is equal to -1, and write another could have copied one that already had the if statement in there. Okay. So we write out the status line, we write out, oh, so there might be a reason. So if reason, no, if message body dot pointer. If message body, so if there is a reason, if we also probably forgot the character return line feed. So let's look at HTTP. Yeah, we forgot that. So if so let's say the string reason is equal to response reason. If reason dot pointer, then we want to, we actually want to do exactly what's happening down here. If this is set, we write that out. Okay. And also we forgot the character return line feed. So now the thing is, we HTTP so this will probably throw a lot of errors. Grow last, or just grow, shrink, grow last. In our HTTP we, oh no, we don't actually need this. So of course the header list is not available to us right now. The header list is not available, which means we have to implement it. Header list. Ooh. I mean, this is just a regular vector. We don't have to initialize these things. We can just say this is result. If the headers is this, we return -1, and we say result header list. Oh, we can just say it's not a header list, but rather okay, we didn't say it's a header list. Header list. Okay, we said it's headers. Headers, equal to headers. Clear HTTP header list, and this just says header list length equal to 0. Hash we don't need. Insert we call push. HTTP header list, and we push a header. Oops. HTTP header. If header list length +1 is greater than or equal to header list capacity, then we want to allocate using the header list. Okay, so this is also a problem because we never free these. Maybe we have an entire arena that is dedicated to I mean, I don't really want to constrain. So this allocation here, this is a problem because we can't really leave it like this. This will grow over time because we can't free in an arena. We can't free in an arena. I don't know what the maximum size of headers is we actually need. So we can't just call allocate. I mean, we allocated we could have some stack allocator that allocates the header list. Is that smart? We could also reuse this header list. Do we have to recreate this header list every time, or can we keep it? I mean, in theory, we could just keep it and clear it and start back over. Then we would only allocate it once. So what we said was write response. So this probably handles the header list. Let's say it is like this. And this handles the header list. So we have so if this fails, we probably want to go to close server socket. No. Can this thing even fail? I mean, it can fail, but it will produce. So this is probably just a void. This is probably just a void. So I hope it's a void. So let's say the response like I don't like this. This wastes memory in the long run. But okay, just init it. I don't know if handle get request. So now we want to say write response this takes a file descriptor, which is the client socket descriptor, and the response. If this fails, this is only due to allocations. And the same thing for this here. But rather we handle the post request. Okay. HTTP header list .cpp, and we allocate using the alloc, and let's set the header list capacity times equals 2, and the capacity times the size of a HTTP header. HTTP header capacity times the size of an HTTP header. Result headers. Okay, allocate this HTTP header star temp headers header HTTP header star, and that is equal to this. For int I equal to 0, I is less than header list length plus plus I. Okay, I think we stop here.